Alright guys, welcome back from Mardi Gras break. I hope you all had a great time. Please excuse my nails that are still painted from Mardi Gras. Hopefully that does not distract you. But anyway, so we are jumping back into Springboard. We are on lesson 24.1, which is defining polygons in the coordinate plane. Now we've already focused on the coordinate plane and we did some graphing, but now we're going to put our shapes in the coordinate plane. Okay, so let's review some of our learning targets. We have draw polygons in the coordinate plane given vertex coordinates. Now vertex, and I'm not sure if you remember this, but we talked about this word just means the corner of those shapes where those two lines meet up. And polygons, don't forget, that is 3 sides or more. So any shape with 3 sides or more. So starting with your triangle and working your way up. Okay, so we're going to draw polygons in a coordinate plane given those vertex coordinates. Next, we're going to find the length of a segment joining points with the same first coordinate or the same second coordinate. Remember, your first coordinate is your x and your second coordinate is your y. Then we are going to use our coordinate geometry to identify locations on a plane. Next, we're going to graph points in all 4 quadrants. And then we're going to solve problems involving the area on the coordinate plane. So essentially, what all of this is we're going to be plotting shapes on our coordinate plane and then find the area of those shapes. Okay? So the situation that we're going to be talking about, we're going to use this for the next 2 lessons in the book. So we have Zena is hired to paint a mural on the side of a large building. I'm sure that you've seen murals, especially if you've gone to New Orleans, where people paint on the side of the buildings. Not necessarily graffiti, but it's more of those pictures that celebrate something or want you to remember something. Okay, so she creates a scale drawing on her mural shown on the coordinate grid. She will use the model to plan the painting. Each block on the grid represents 1 foot by 1 foot. So 1 by 1. Okay, so that's our measurement. We're working with feet. Okay. Next. So this is our mural, right? So it looks pretty cool. We got a lot of shapes. I'm sure you might see some triangles and some squares and parallelograms. Have a whole bunch of stuff going on here. Okay. So we have number 1. It says the border, or your outline of Zena's design forms a quadrilateral WXYZ. So W, X, Y, and Z. On a coordinate plane, sometimes you'll be given those letters just so you know what you're working with. Okay, and remember this quad, right? That means 4. So it's shapes with 4 sides. So the first question says, what are the coordinates of point W and X? Okay, so let's see. W. Oh, I gotta count all of this, but let me find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I go to the right 15, so that's a positive. Remember, we always go left or right first. And then we need to go up or down next. So W is up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I went up, which is positive. So my W is 15, 15. And then X, well, I noticed that X is pretty much the same height, right? It goes up the same height. So I at least know what my Y is going to be, which is 15. But let's see this way. 1, 2, 3, 15. So we went a negative 15 because we went to the left, right? And then we went up the same amount as the W, which is a positive 15. Now, I want you to answer B on your own. I'm not going to give you that one, but it says, what do these coordinates have in common? So what is the same about them? So we have positive 15, and negative 15, positive 15. So what is in common? What is the same about both of these? All right, hopefully you've answered that, and I've checked it. Now going to the back, it says, what is the length of side XW of quadrilateral? Explain your answer. So this is just that line above the X and W just means that line segment. So let's look at Z and W. Is it Z? I'm sorry. X. It was X and W. So I want us to look at this line segment here. And it says, what is the length of this? So from X to W, what would this length be? And explain. Well, from the x-axis, not the x-axis, y-axis. From the y-axis, I'm sorry, Ms. Wallen cannot speak right now. From the y-axis to, let's go X, right? That was, technically we went negative, right? But is distance ever negative? Hopefully you know that that is a no. So from the y-axis to X, technically we went 15 feet, right? So then from the y-axis to W is also 15 feet, which means that my total length, hopefully you're getting it, total length is wait for it, 30 feet, because I'm adding, if I'm going 15 feet this way, 15 feet this way, collectively the whole thing would be 30 feet. Okay, so we just measured from left to right, and collectively is one big thing. Even though that other 15 was negative, distance is never negative. So for D through G, basically we're doing the same thing that we just did from A through C. Okay, so D wants to know what's the coordinates of point Z. Then what do the coordinates of point W and Z have in common? Remember, that's the same. Once you figure out what they have in common, then they want you to find what is the length of WZ and then explain it. And then G, just a little teasers, just to let you know what best name, right? So let's try and figure out, looking at that shape, what is going to be the best name based off of the side measurements for this quadrilateral. And then you need to explain why. Okay, and I'm going to say this, it needs to be something about the sides. You should have the word sides somewhere in your answer. Okay. All right, so you're going to work on D through G, and I will be coming around to check your work. All right, so hopefully you're done D through G, and I want you to come over here, and we're going to write some little notes. So there was a pattern going on here, and I'm hoping that you noticed the pattern. So I'm going to write the pattern right here just so we know what we're talking about. So you should have noticed that when the first coordinate of 2 points are the same, that means that we're going to have a vertical. And remember, vertical is going up and down. You're going to have the vertical line is formed. So when the first coordinate of 2 points are the same, right? Remember that first coordinate, so this is basically our x. If the x's are the same, then you're going to have a vertical line. On the other end of that, when the second coordinate of 2 points are the same, that's going to equal horizontal, which is left and right. Your horizontal line is formed. That would be our y. So again, when the first coordinate, so your x's are the same of 2 points, it'll be on a vertical line going up and down. When the second coordinate of the 2 points are the same, then you're going to have a horizontal line. So that's left to right. Okay? All right. Let's go down here to number 2. It says, consider only the portion of Zena's design in the first quadrant. So this is just in the first quadrant. The vertices, remember that's our corners. Okay, that's where those lines meet. Okay, so the vertices of the inner square, so that's this square right here, labeled A, B, C, D. So A, B, C, D. So we're working with this square. It says the coordinates of point B are 11, 5. So right here, that means it goes to the right 11 and it went up 5. It says, what are the coordinates of point A? Well, if it's on the same vertical line, right? Same vertical line, then our X is going to stay the same. So if this is up at 5, now we have to count up to A. So 5, 6, 7, 8, 9, 10, 11. So point A is at 11, 11 on the grid. So now I want to know what is the length of AB. So just from A to B, what is the length? Well, if B was at 5, right, and then A is at 11, the distance between those would be 6 feet. And remember, I got feet because originally in the beginning it told me that it was 1 foot by 1 foot measurements. Okay. Now, so that was the length. Now we want to find what is the area. So, okay, let's think about this. If I'm working with a square, right? Is that what they told us? Yep. So we're working with a square. And I know that this one side is 6 feet. That means that every side must also be, think, 6 feet. So every side is 6 feet. Remember, the area for a square is area equals base times height. Okay, so I'm going to let you figure that one out. You should substitute in what your base is and what your height is, and then don't forget your units at the end. Okay, because remember, if we don't have feet squared, you don't get it right. Okay, so make sure you always get those points for those. All right. All right, moving on. Number 3. It says, explain how to find the length of a vertical line segment using the coordinates of the endpoints. Include an example in your explanation. Okay, so this one says we're going back to all this. How could we have found this distance from A to B without counting from this grid? Like if I just were given the coordinates of A and B, what operation could I use to find this answer? Okay, I know I had this poster up in my room for a long time when we talked about this. So what operation could I use with those two endpoints to figure out the distance? Think. Hopefully you picked subtraction. Okay, so we could just subtract the y coordinates. That's all we gotta do. So I'm gonna give an example. Let's say I had 1, 2, and 1, 6. So my x's are the same because they're gonna be on a vertical line. When I subtract 2 from 6, right? So 2 minus 6, I'm gonna get 4 is my length. 4 is the length. Same thing if I would have been up here, right? So if I had 5 and 11, 11 minus 5 gave me 6. So this next one is basically the same question, right? Explain how to find the length of a horizontal line segment using the coordinates. So if here we subtracted the y, right, because our x's were the same, then here, hopefully you can figure out that we are going to subtract the x coordinates. So for example, if I had, let's do 1, 2, and 8, 2. So now my y's are the same, so I need to subtract my x's. So I do 8 minus 1, I get that segment is 7. Okay, whatever the measurement might be. But here's my question I want you to think about. Does it matter the order of subtracting the coordinates. Doesn't matter the order when I subtract these coordinates. So let's go back to number 3. I did 6 minus 2, but what if I had done 2 minus 6? What would I have gotten? Hopefully you've said -4. But is distance ever negative? No. So you would have still gotten 4, but you would have to remember, okay, distance is never negative, so it's just 4 units. Same thing down here. If I would have done 1 minus 8, I would have gotten -7. Again, distance is never negative. So don't freak out when trying to, oh God, which one do I subtract from what? It doesn't matter. As long as you subtract it, you'll be fine because you're going to get the same number. You just got to always remember and tell yourself, distance is never negative. You're never going to travel a negative distance. It's not a thing. Okay? All right, let's go to the next one. So, number 4. The endpoints of a line segment are -4.56 and -4.5, -2. In the My Notes section, create a coordinate grid. Draw the line segment on the coordinate grid. All right, so I'm going to do this over here, and I'm going to tell you exactly how many I'm doing so that we make sure that we know all that we're doing. So I'm going to count 1, 2, 3, 4, 5 over. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So I counted 7 down both ways and 5 over this way. All right. So I have -4.56. Let me zoom in a little bit. There we go. Okay. So -4.56 and -4.52. I'm sorry, -2. So I'm going to do the first one. I'm going to go over -4.5. So 1, 2, 3, 4. And this 4.5 is going to go right. Oh, I shouldn't have plotted that. It's okay. -4.5 and then 6. 1, 2, 3, 4, 5. Oop. This needs to come right up there. Okay. Ignore this red dot. Don't plot that. Okay, then I need to come back over here to -4.5 and go down to -2. 1, 2. So now I have this line segment on my paper. B says, what is the length of the line segment? Explain how you determined this length. Well, zoom back out a little bit. So if I go up 6, and then I went down 2. The whole thing. Well, let's use my coordinates, right? 6 minus a -2. Remember this, we change this, take the opposite, right? So 6 plus 2 gives me 8. So my distance, my line segment, is 8 units. And whenever you do an explanation, right, because it wanted you to explain, you can explain with words, but you could also have done this. And this is a perfect explanation. So on LEAP, you can either show the math, or you could have written saying, I subtracted 6 and -2 and got 8 units. So either one is fine. You can write it out like this, or you can put it into words. Okay? All right, next one, number 5. Looking at this parallelogram, ADPR, in Dina's first quadrant design, what is the length of the base of the parallelogram AD? So I want right here. So from A to D, I'm going to count 1, 2, 3, 4, 5, 6. So that is 6 feet. Okay. Well, what is the height of the parallelogram? Explain how you determine this. Okay. Well, I know that my height is never on a slanted line, so I can't actually count from here to here, okay? So I'm going to count from D right here to PR, line segment PR. So 1, 2, 3, 4. So I know it is 4 feet. And your explanation is that you just counted the number of units from D to PR. And that's a perfect explanation right there. Exactly what you did, you just put into words. Now, C, I'm going to let you do that one. You want to know what is the area of this parallelogram. Okay, so again, your area equals base times height. Substitute in your base, substitute in your height. Okay, so I will be coming around and checking those in. I'm sure I've been circulating already, but I will be coming to check those. You need to make sure that you have C correct before you can actually move on to number 6. Okay. Okay, so number 6, what is the total area of the parallelogram in Zena's first quadrant design? Well, we know that we have 2 of these parallelograms that are actually the same measurement. So if I have 2 of these parallelograms times, hopefully you've already gotten this from 5C, 24 feet squared each. Okay, so both of them are 24 feet squared, and there are 2, which means, drum roll please, 48 feet squared for one quadrant. So only in quadrant 1, 40 feet squared, so this is quadrant 1, okay, which is going to lead us to part B. Each of the 4 quadrants has 2 of the light blue parallelograms in the mural design. So these are the light blue ones. I know it's hard to see it on my paper, but you should see it in your book. It wants to know what is the total area of the light blue parallelograms in the whole mural. So if I know that in one of them it's 48 feet squared, and I have 4 quadrants, that means, I'm gonna let you figure that out. What is the area of all of the parallelograms? So there's 48 feet in each quadrant. There's 4 quadrants. So we need to multiply 48 feet squared times 4, and you will get how many, what is the total area of the light blue parallelograms. Okay. Okay, so now C wants us to take what we found out, what we know, and we're going to apply it to a real world situation. Okay, so it says each gallon of light blue paint costs $45 and will cover 75 square feet. How much will the light blue paint cost that is needed to paint the light blue parallelograms in all 4 quadrants? Okay, so let's think about this. You should have gotten from letter B that those 8 parallelograms are going to equal 192 feet squared. Now, I can cover 75 square feet with my paint. So I need to see how many gallons I need. So 192 feet divided by the 75 feet that each gallon will cover gives me 2.56 gallons. But I'm not going to buy a can that's only going to have a 0.56 gallon or things like that. So I'm going to actually round this to 3 gallons that I need. Okay, so if I need 3 gallons times $45 per gallon, how much money are you going to wind up spending on paint? So I'm going to let you figure that out. So I have 3 gallons of paint that I need times $45 for each gallon. So how much total money will be needed to cover this mural? Okay. So, all right. We're only going to do the check your understanding part on this page. Don't worry about the lesson practice. That'll come in another time. Okay, so it says use the coordinate grid, that's right here, for numbers 7 through 10. So it says the vertices, which again, hopefully you know this by now, or the corners of rectangle JKLM are represented by these coordinates. Draw the rectangle. So they want us to plot these points. Okay, so let's see. J is at a negative 2.5. So 1, 2.5, and a positive 3. 1, 2, 3. Then we have, so I'm just going to label that as J. Then K is at 2, 3. So 1, 2, and then up 3. 1, 2, 3. So that is K. L is at positive 2, negative 1. And that again is L. And M is at negative 2.5, 1, 2.5, and a negative 1. Okay. Oh, sorry, guys. So this is our rectangle. So you can go ahead and connect these dots. Okay. Now, number 7 says, what is the length of side JK? Oh, let me fix this real quick. Oh, sorry. Okay. So JK. Well, I know that for K I went over 2. For J I went over 2.5. So 2.5 plus 2 is going to give me 4.5. Okay, so that length is 4.5 units. Okay, now for JM. Well, J went up, how many? 2.5, and then M went down 1. So this is 2.5 plus 1. I'm sorry. J went up 3. So let me rewrite this. That is my bad. And that's why we need to write with pencils, guys. So 3.1, which means it's a total of 4 units. So I want to know the area of the rectangle. Well, area equals base times height. We have our base, right, because we're going left and right, and then our height. So we're going to use these two answers to find our area. So does it matter the order that we write it in here? Nope, because it does not matter. 2 times 3 is the same thing as 3 times 2, right? So you need to do 4.5 times 4 and get your final answer. Okay. Once you are done with that, you are going to get on iExcel, and the iExcels will be posted on the board. They're going to be your area and your coordinate grid iExcels. All right. That is all. Hopefully you have learned something in this lesson, and you've remembered a lot of your coordinate plane information to help you with all of this.